So section 3 is about what's called matrix multiplication, which is different than scalar multiplication, and it's more complicated. So this is, the hard, the most difficult of all the different operations we're going to talk about. This is definitely the most difficult one. So first off, this is important. The number of columns in the first matrix has to be the same as the number of rows in the second. So I'm going to have two examples here, both of which are okay. In class, what I think I might do is just throw a whole bunch of them all up there and see, you can talk about whether or not they're possible without even actually doing them, because that is an important first step. Both of these examples are examples where we can do them. Alright, and let me show you how you can tell relatively easy. If you're good at writing down the dimensions, I'll show you what to look for. So if you know how to write down the dimensions, this is a 2 by 3, and then this is a 3 by 2. Okay, and as long as these two middle things match, okay, so 3 and 3 in this case, it's possible. Okay, and not only that, if you actually mark off these middle ones, look what's left over, 2 and 2. Turns out that the answer will be a 2 by 2. Alright, so if you write the dimensions out like we've been writing them, it's only possible when the middle two match, and if you cross out those middle two that match, so 3 and 3, what's left over tells you the dimensions of the answer. So the answer here will be a 2 by 2. And actually, before I actually do anything else, let me show you. This one will be similar. So this is it's a 3 by 2. 3 by 2. And well, if you notice, it's just the same thing we were just doing. Same two matrices, they're just switched. And then times this is 2 rows, 3 columns, so it's 2 by 3. And so this one's possible as well. Okay, and if we take the middle ones, and the reason why it's possible because these middle two things are the same, what we'll get is a 3 by 3. Okay, so there you go. So what do we do? What do we do? Well, what you do is you take each row. So you go, let me erase this stuff here. Alright, so you go across the first, you pick a row. I shouldn't say you pick a row. You go with first row and first column. Okay, and what you do is I'll show you. It might be easier to see. You go to the first element in each thing you're looking at. So first row, first column, same thing here, and multiply. Then you go the second element in that row and match it with the second element in that column and multiply them. Third element in that row, third element in that column, and multiply them. So you have 3 different numbers there when you do that. So this is matrix multiplication, so all I'm doing is multiplying, at least so far. So I pick the first row and first column and kind of match up the elements. That's why what's in red here is the case. Alright, if what's in red here wasn't the case, you wouldn't be able to match them element by element. You'd run out, if there were more rows in the second matrix, then you'd run out. You wouldn't be able to match. You'd have to get a 3 with a -2, and then you try to match it with something over here, and we're out of elements. Alright, so they have to be exactly the same. That's the whole point. Alright, otherwise stuff doesn't match out. So -1 times 5, 2 times 9, 3 times -2. So let me actually write that out. Okay. So -1 times -5 is +5. 2 times 9 is 18. 3 times -2 is in the way is -6. Okay, and so what do you do with those things? Well, you add them. Okay, so when you do, when you match a row in the first one with a column in the second one, you end up with 3 different parts to your answer. 3 different multiplications. In this case it's 3 because the row is 3 across and the column is 3 down. Okay, and then you just add them up. So like I said, this is going to be a 2 by 2, and I probably didn't leave enough space. Okay, definitely for these problems, when you do them, you need a lot of space, unless you're just going to do a ton of stuff in your head, which is questionable. Of questionable wisdom. So 5 and 18 minus 6 gives us 17. Okay, do the same thing. Go across, and it doesn't matter the order in which you do them in. I kind of stick with the same row in the first one, and then go down the second column here. That's totally just a matter of preference. It really does not matter at all. So you go from -1 times a +1. So first one times first one. Second one times second one. Third one times third one. Okay? So, -1 times 1, -1. 2 times 0, so I'm going to write it. Now keep in mind, remember like what I said, we're adding the whole time. We're adding and multiplying at the same time here. Multiply 3 things, get 3 products. 3 pairs, get 3 products, and then add those products up. So 1 times -1 is 1. Or excuse me, -1. 2 times 0 is 0. 3 times 7 is 21. Okay, so we end up with 20 when we add up those 3 things. Okay, that's a 21. Okay, and then we go across the bottom row and down the first column. Okay, so across the first row, or excuse me, second row, we go 4 times -5, so it's -20. 5 times 0, oops, I'm in the first column, not 5 times 0, 5 times 9, so plus 45, 5 times 9, and then 6 times -2 is -12. So we do that, we get 13. Okay, and like I was saying, make sure to leave plenty of room. Alright, which I did not really necessarily do. Oops. Alright, this is a little bit better. Okay, and then last but not least, we do second row, second column. So 4 times 1, 5 times 0, and then 6 times 7, so 42. So okay, ignore that 42, that's horrible. 4 plus 42, well, plus 0 is 46. So this is the answer. Okay, so notice, like I said earlier in the video, you should get a 2 by 2, and there you go, it's a 2 by 2. So let's do one more example, and then I'm sure this is the hardest thing in the chapter so far, I think, clearly. Alright, and so let me make it clear that, you know, this multiplication problem, this matrix multiplication problem, the answer is this 2 by 2 matrix. So this times this matrix times this matrix gives you this. Okay? Alright, so let's do the same thing with the, you know, with the switcheroo. Okay, so notice our answer is going to be 3 by 3. I guess this is not a bad time to point out, matrix multiplication works different than regular multiplication that we're accustomed to in, you know, just multiplying numbers. So multiplying numbers, if you switch the order in which you do them, you get the same answer, it doesn't matter. Alright, if you switch matrices and multiply them, one, it's possible that you turn a, you know, a problem into a doable problem into an impossible problem if you do that, for one thing. And then not only that, in this case, what you get is, well, I erased it, but you get a 3 by 3. Here our answer is a two row, 2 column. If we switch them, if we make it the opposite problem where it's, you switch the matrices, so this is the same two matrices, we just switch the order. Well, this is going to be a 3 by 3, so obviously it must just be different. Okay, so switching the order of multiplication matters. You get a different answer. So let's just go through one more example here, and we'll probably do some more in class, in all likelihood, because these are hard. Okay. Alright, so across and then down. So 3 by 3, so I'm going to make a real big one here. Okay, first row, first column, -5 and -1. So we get 5. And 1 times 4. You can already kind of tell this is going to be suspect. We might not have enough space here. Alright. Then we do, like I said, I like to stay in the same row and then just move down columns. So first row, second column, 5 times -2. 1 times 5. Okay, and then first row times last column, so you get 5 times -3. Excuse me, I said that backwards, but -5 times 3 is -15. Okay, and then 1 times 6 is 6. Okay. Now we do the second row, first column. So 9 times -1. 0 times 4. Okay, and just reiterate. Now I'm in. Oops, wrong thing. Now I'm going to cross. All right. So, like I said, now we're in the middle column, or middle row, excuse me, the second row. And we're going to go through each column. So down, middle row, middle column actually, and lo and behold, you're in the very middle of the answer. When you do that, you get 9 times 2, 0 times 5, so it's plus 0. Heck, we know we're going to get a plus 0 here too, if you think about it. We do 9 and 0 times 3 and 6 now, so middle row, last column, we get 9 times 3 is 27. Okay. Like I said, leave a ton of space for these because you're going to do a lot of calculation in these, and really there's nothing. The only thing you have to separate elements in your answer matrix is space. So if you don't leave enough space, it's going to be totally a mash of numbers, and it's going to be super confusing. Okay, it's already confusing enough. So last column, or excuse me, last row, we go across this bottom row and then down each column. And so -2 times -1 is 2. 7 times 4 is 28. So there's nothing, I mean, it's just complicated is what these are. It's not like there's some really abstract, crazy idea going on. You just got to be real careful. Okay, across the bottom, down the middle, so -2 times 2 is -4. 7 times 5 is 35. And then last but not least, bottom times last. Okay, and so hard part's done. Now we just have to add all that stuff. So we get 9, -5, -9, -9. Okay, and then so on. I'm going to leave, what I'm going to actually have you do tomorrow is try to finish this. That'll be your do now. The second, check and see if you watch the video. So it'll be related to this. I'm not going to tell you exactly what I would expect you to do. But, alright, so there's a couple of examples of matrix multiplication. We'll do a bunch more tomorrow. But there you go.